Hey, welcome to the Swiftbird. I'm Yakov, and I hate writing bash scripts. To be fair, I don't have to do it very often, but at this point I'm not even sure if it's a pro or a con. Anyway, as someone who primarily works with Swift and really enjoys its static safety checks, I find bash pretty confusing, maybe even alienating. Like, I don't feel very confident when my mistakes become apparent only when it's too late and the code is already running. And since some sort of setup or maintenance scripts are pretty ubiquitous in iOS and macOS projects, I decided to explore alternatives to bash, specifically one alternative: Swift scripts. The Swiftbird is a small channel where I explore tech and software. If you support what I'm doing here, you can show it by liking this video, subscribing to the channel, and maybe even sponsoring it at the links below. Now, my script for this video says it's time to go back to Swift scripts. First of all, let's talk about what's wrong with bash. And if I'm being fair to it, nothing's really wrong. It's just a tool that has its own purpose and, if you will, its own character. Any problems arise when you work with it occasionally, not trying to become an expert in bash scripting. In that case, some of its paradigms may confuse you, and it's not just about bash, it's basically the same thing with any cross-paradigm transition. Like, I know people who are experts in Python or JavaScript, but they feel very uncomfortable using something more demanding, such as Swift or even TypeScript. In my case, it's the other way around. I'm used to relying on the compiler to check my code for accidental mistakes, so I don't have to worry about reassigning an integer variable with a string. Instead, I can focus on the architecture and other high-level concepts. On the other hand, you don't really need to think about architecture in a 50-line script. Using something more flexible such as bash totally makes sense. So in the end, it always comes down to the context. However, just as I said, I'm okay with the strong typing and static checks of Swift, and I would prefer them over something much less familiar. Now that I've explained why you may want to use Swift scripts instead of bash, let's see where you can use them. The short answer is everywhere. Swift scripting, just as Swift itself, is available on every major platform: macOS, Windows, and who knows how many flavors of Linux. But there's a catch. You see, any script is just a text file. It cannot do much on its own, because the text needs to be interpreted by an actual program. The first line in a script tells the computer which program should run it. Every Unix-based system has the tools for running bash scripts, and Windows has them too if you enable WSL. But Swift is not installed by default even on the Mac. So the full answer to the question is, you can use Swift scripts everywhere, as long as you have Swift installed too. Installing Swift is a one-off task, but still, keep this in mind. Before I start showing the actual scripting in Swift, I'd like to give you a quick resume comparing Swift to bash. But if you already made up your mind to try Swift scripting, feel free to skip to the next section. I personally have three primary criteria for any technology I'm gonna use: how much I need to start, how well it fits into the rest of my stack, and how compatible it is with different scenarios. I've been working with Swift for nearly 6 years, so I can totally check off the first item. To me, Swift is much easier and more familiar than any other language, period. Since I mostly work with iOS and macOS projects, scripts written in Swift fit perfectly into the code base. I'm checking off the second item too. However, Swift clearly loses in compatibility for the obvious reasons. By default, you cannot run Swift scripts on a fresh new computer. It's gonna need some preparation first. And if you rely on the CI which doesn't have Swift pre-installed, this can be a problem. This is my personal list. Of course, yours may be different. But to me, Swift provides enough advantages over bash to switch. So here's how you do it. Because you're watching this channel, I assume you already have Swift or Xcode installed on your computer. That's good news, because it means you don't have anything extra to write and run Swift scripts. But to give you the full picture, I'll set up everything from scratch on Ubuntu. Okay, to simulate Ubuntu, I'll be using GitHub Codespaces. Right now I'm starting a new codespace in an empty repo, and once it's created, I'll be able to use an Ubuntu instance hosted in the cloud. Codespaces is finishing its setup and installing the extensions I have synced with my GitHub account, including the official Swift extension for VS Code. Alright, seems like everything's ready. To install Swift on Linux, you need Homebrew, and to install Homebrew on some systems you need certain additional dependencies. You install them with this command, which I copied from Homebrew's website. But Codespaces seems to already have them. After that, I paste the actual homebrew installation command. It will download everything that's needed and install it to my Linux system. Okay, homebrew installation is done. There's a couple more commands that need to be executed so that the command line can resolve homebrew itself and the tools you install with it. To make sure everything's installed correctly, I'll make another terminal instance and check the version of brew. And here comes the actual installation of Swift. I can check the package's metadata and see that we'll be installing Swift version 5.8, which is the latest version as of today. And then we just tell brew to install Swift. Then we wait, and wait, and wait. Swift is now installed, and to make sure I didn't mess up anything, I'll create another terminal and run Swift version. And yeah, I have Swift version 5.8.1 installed on my Ubuntu computer. Now that the scripting environment is set up, let's start with some basic operations. Printing, calling functions, and reading user input should look very familiar to everyone who's written any Swift code. You use the print function to output values from your script, and readline to acquire the input. Okay, so now that Swift is installed, I can create a file. Let's call it hello-world.swift. The file opens, and the first thing I want to do is make sure this file is interpreted by Swift. I do it with this line, which tells the system it's the Swift executable that should interpret this file. And I can check it right away by running swift hello-world.swift. Nothing happens because I don't have anything in this file. Just as I mentioned before, you use the print function to output something. I run the command again, and here's that hello world string printed to the command line. But I want something more interesting, something that can demonstrate printing, input reading, and functions. So I remove all this and instead create a function called sayHello2, which takes the name parameter of type string. The only thing this function will do is say hello to name. Next, I should ask the user for their name, and for that I use the readline function. I know in iOS or macOS development you don't really see this function that often, but in scripting it's pretty much ubiquitous. This function returns an optional string, so you can already see some of Swift's safety mechanisms in action. In this demo, it's okay to use force unwrapping. After that, I say hello to the name. And in the beginning, I'll add a prompt so the user knows what's expected of them. Seems that I'm done, and what I can do is just execute the script. What's your name? I'll type my name. And it greets me. Alright, that's great. Oh, and one more thing. Scripts are considered something like a self-sufficient thing, so usually you just call the script directly and let the system figure out how to run it. If I try it, I'll get an error because I don't have the execute permission on my script file. This can be added with the standard chmod tool that's available on macOS and Linux. After that, the script just runs without you knowing which program is actually doing that. In my experience, Swift really shines when it comes to splitting your logic into separate functions. You can pass parameters, receive return values, and do everything else available in Swift. Best of all, the compiler checks your code before it runs, so you have a zero chance to make a mistake. Now, the beauty of scripts is their ability to call other commands. Swift scripts support all the features you'd expect, such as passing arguments and receiving the output. But I don't want to sugarcoat it, so I should note that in Swift, such calls don't look as simple and elegant. So, let's try calling other commands. I'll create a separate file, and in this file I'll copy the first line from my hello world script. Basically, when you want to call a command, Swift wraps it in a process object. I want to call the ls command to list the files in my repo. I create a process instance. Alright, we need foundation for that. I created my process, and then I need to specify the URL of the executable. I use the same trick I used here, meaning that my executable will be resolved by the system dynamically, so each system where you run the script can figure out the right path. Technically, my actual command will be in the arguments, not the URL. I want ls, and I also want to see hidden files, so I add the a argument. What I do next is I wrap my call in a do-try-catch block. I type ls.run, and as you can see, run is a throw-in function, so Swift is once again helping me avoid mistakes. In the catch part, I'll just print the error's description. Let's see what we have. I'll make my script executable and then just run it. Now you can see the contents of my repo, including any hidden files. Of course, this is not something you want to do every time. What I usually do is abstract away this thing in a function called call, where I specify the name of the command and arguments, which by default will be empty. This function throws, but if you want, you can handle any errors inside this function. Then I basically move this block of code inside the body of the function. I should probably rename ls to process. What I need is to pass everything to process's arguments. I no longer need the do-try-catch block. And then I can try calling it. The same result. But what if instead of printing something to the console, you want to get some data in a variable and then use it somehow? That's pretty easy, and I can just update the existing function. I'll add optional output and then create a pipe. This is a mechanism for redirecting streams of data. What I do is tell Swift that whatever my process returns should go into this pipe. Next, I need to actually read the data from the pipe, and I do that with the following construction. You don't often see a function which both throws and returns an optional, but read2end is one of them. This function returns data, so I use the common technique to convert it to a string. Everything else is pretty clear. If there is some text in the pipe, I return it, and otherwise I return nil. Oh, and I just noticed that I don't actually need the pipe to be a variable. Now I want to test my script. I'll update the existing function call to make it save the return value to a constant. Since we're getting an optional, what I can do is provide a default value. You don't have to do it, but without a default value, your output will not look as nice. Yeah, you get the same warnings Xcode would show you, except Xcode shows them right in the source files, and here you get them in the console. One thing I can improve is about the run function. Certain commands which, for example, sort a lot of files, may take some time to finish, and before we actually read the data from the pipe, it's a good idea to wait until the program exits. This way, I'll be sure I don't try to pick up the data from the pipe before it's ready. Okay, here's another task. What if, instead of reading the current directory, I wanted to view files in some other place? With my current setup, I'll have to change the script, which isn't very convenient. Normally, you expect to be able to pass the directory path using script arguments, like that. But as you can see, it doesn't work, because my script completely ignores any arguments. So let's go ahead and change that. I'll create a new file called showContents. First, I'll just copy the existing script, and of course make it executable. But then I'll read the arguments from the command line object. It also comes from Foundation and works on all supported platforms. Arguments is an array of strings. You don't have to split the input manually, because command line does it for you. Then I just pass the input arguments to my call function. I hope I didn't forget anything. For now, I want to see all files, including hidden ones, in the current directory. But then, if I want to view another folder, I just change the argument. So, as you can see, calling other commands from a Swift script is not very hard. It takes more code, but in return you get more safety. Another common operation is reading and writing files. Doing so in Swift takes a bit more work, but it's still not that hard. To work with the file system in Swift, you use the file manager, which may be familiar to you from iOS or macOS. At the same time, there's one crucial difference, and it is the directory structure on the Mac, Linux, and Windows. macOS has a number of well-known places where you typically put your stuff. For example, pictures, documents, applications, and so on. To easily work with those folders, File Manager provides shortcuts in the search path directory enum. Windows has similar folders, though in different locations. But Linux system may have very strange file structures. Most often, however, scripts only need to access some neighboring files. For example, they may read a configuration stored in the same repo, or write some logs. For that, you basically want just one thing, the current directory, and File Manager provides a computed variable for easy access. So in this demo, what I want to do is read a text file and then update its contents. I'll start with creating a URL for the current directory. I use the standard URL initializer and provide the current directory path as its input. Technically, File Manager doesn't really need a URL to read files, but using them is more safe than using paths, which are just string literals. For example, I can append my file name without thinking about which kind of slash I should use. Besides, I'll need a proper URL for writing data. Once I have the file URL, I can ask File Manager to give me its contents. It returns data, so I once again create a string with it. Then I just print it. Let's try running the script. And yeah, it works. What I want to do next is add some more text to my file. Strings have a very nice method called write_to, which does all the heavy lifting. Here you need a URL because a path won't work. I wrap the call in a do try catch block and just print the potential error to the console. Keep in mind that write method replaces the data, not appends it, so I need to reuse the original contents. I guess I'm ready to run the script once more and see what I get. Seems like everything works and I get the updated file. As you can see, working with files in Swift scripts isn't that hard, even though it does have some nuances. So far, I only spoke about interpreted Swift scripts, but with a single command you can compile them into full-fledged binaries. This way they run faster and don't depend on any software installed in the system. Here's an example of when you can find it useful. At one of my previous companies, we had a script that did some bootstrapping and maintenance. It ran every time the project was built. The script was written in Bash and had a lot of business logic. So when I needed to change a couple of things in it, I'll be honest, I didn't feel very comfortable because it seemed like any change could ruin the entire script. I volunteered to rewrite it in Swift and at the same time switched to the binary form. As a result, we got a script that was much easier to work with. And as a bonus, we were able to cache the binary on the CI and boost the performance. Okay, here's the show content script from a previous demo. As you can guess, the script will only run if I have Swift installed on the computer. That may not be the case with certain continuous integration systems. What I want to do is compile the script and make it a standalone binary. You do that with the swiftc command. Swiftc is the actual compiler component of the Swift package. Swiftc has a lot of configuration options, and you've probably seen them in Xcode's build settings. For now, I don't need any of them. I just call swiftc and specify the source file. The command is compiling the code, and once it's done, I get a new file in my repo. It's binary and contains everything needed to run the script, although it's no longer a script but a program. I'll recompile the source, but this time I'll enable the standard optimizations. As you can see, the binary has reduced in size. Of course, you can go hardcore and make it even smaller. I'm basically done here, but there's one thing I want to highlight. If you ever wondered how the Swift compiler works, you may have heard about LLVM's intermediate representation. It's similar to bytecode in Java and can be run on different machines. But what you see here is not the IR, but the actual machine code, which means it's architecture dependent. This program, for example, won't run on Apple processors because it was compiled for x86. The Swift compiler lets you specify different targets, and you can even combine different executables into a universal binary. I won't go into details, but you can let me know if you want to learn more about this. Maybe I'll make a separate video. Let's have a recap. In my opinion, Swift scripting is a viable alternative to Bash in many scenarios, but not each of them. If you only want to call a couple other commands, then it's probably not worth the hassle. But when you need the script to have some complex logic, Swift gives you more safety, performance, and peace of mind. And now it's time to wrap up. I hope this video gave you an idea of why you may want to use Swift scripts and how you can set them up. If you found it helpful, please give it a like and subscribe to the channel. And if you have any questions, don't hesitate to leave them in the comments below. As always, you can also support the Swiftbird at the links in the description. I'll see you later, and until then, make your scripts fly.